Hello. So in this video, I'm going to introduce kinetic energy and the definition of kinetic energy. And this is going to be the short one, so you'll like it. Okay, so I'm just going to go straight into a whiteboard now. Share the screen on the whiteboard. Let's see. Okay. Password. Okay, kinetic energy. Chapter 7. So this is chapter 7, kinetic energy. Chapter 7. And we've been working on work and potential energy, and this is kinetic energy. Remember, in mechanical energy, there are two kinds of mechanical energy. One is a potential energy, the one that we defined in an earlier video. And then there's another kind of energy that's kinetic energy. From the naming, you can imagine that kinetic energy is that any moving object possesses some kind of an energy, and that's the kinetic energy. So kinetic energy is the energy of motion. Energy of motion. It's the energy of motion. Just gonna give you the definition straight. Kinetic energy is equals to 1/2 times mass of the object. So the heavier the object is a bigger kinetic energy, and the speed, how fast it's moving, but it's square. Again, its unit is in joule, right? And it's a scalar. All the work and energy, they're all scalar. Don't contain any information about direction. So that's it. This is the definition of a kinetic energy. Let's see. So that's 1/2, or you could just write as a KE, kinetic energy, as 1/2 mv squared. So again, the bigger the mass, bigger the inertia, bigger the object is, the mass, more massive that is, you contain more kinetic energy. Makes sense, right? Imagine that, what is it? The big bowling ball that's moving compared to the tiny leaf that's moving with the same speed, both of them, you would imagine that bowling ball would contain more energy, and that's kinetic energy. To have the same speed, bowling ball has that bigger kinetic energy. And of course, if you're moving faster, you're going to have more kinetic energy than the object that's same object, but it's moving slower. So that's kinetic energy. But interestingly, it's squared. So if you move, let's say you're moving, and then if you move twice of the speed, actually your kinetic energy doesn't just double, it's going to quadruple, becomes 2 squared, so it becomes 4 times more. So it goes by the square of a speed. All right. So what does it mean? What does kinetic energy 0 mean? What does this mean if you have a 0 kinetic energy? Does that mean the object is it moving in a constant motion in a straight line? Does that mean object is moving in a backward direction? does that mean object is at rest, right? Kinetic energy equals 0 means object is at rest. If an object is moving, constant speed, straight line, you're still moving, so you still possess kinetic energy. All right. So when kinetic energy is 0 means it's not moving, it's at rest. All right. So can you have a negative kinetic energy? Can you have a negative kinetic energy? Is it possible ever to have a negative kinetic energy? Well, let's look at the definition. Kinetic energy equals to 1/2 mass times velocity squared or speed squared, right? 1/2 is 1/2. Mass, can you ever have a negative mass? No. Mass is mass, always positive. Can you have a negative velocity? Yes, but it's squared, velocity squared. So you're always going to have positive. That means you cannot have a negative kinetic energy. Never. No negative kinetic energy. Can you have, besides this, can you have a negative gravitational potential energy? Remember? Yes. You can put 0 of a gravitational potential energy anywhere. You can choose. You could put it in up in a space far away from where you are, and you become definitely minus big number. So yes, negative gravitational potential energy, yes, but you could never have a negative kinetic energy. Okay. Yeah, so that's it about the definition of kinetic energy. Okay, so in next video, I'm going to talk about work energy theorem. Nice and short. Okay. Okay, I'm going to see you in the next video.